Welcome to Ask and Learn.
All right, so for this function, we have the domain is x is all real. We have an intercept at 0, 1. There is no symmetry. And for asymptotes, we can test the limit as x approaches infinity. X approaches infinity of our function e to the inverse tan of x. Okay, and that turns out to be e to the power of pi over 2, which is approximately 4.8, just so that we can graph it. So that we have, as x approaches infinity, we're going to have an asymptote at y equals about 4.8. So we'll just put at 4.8. And let's see what happens as x approaches negative infinity. So, all right. So what would the answer be if this was as x approaches negative infinity? Our answer is going to be e to the power of negative pi over 2, which is approximately 0.21. So we can put y approaches about 0.21. So those are our asymptotes. And now we can use the first derivative test to see the increasing and decreasing intervals. So y prime equals e to the inverse tan of x over x squared plus 1. Okay, and if we set that equal to 0, we see that it's inconclusive. Okay, so we can't use the first derivative test, but we can still look at y double prime for concavity. So we have e to the inverse tan of x minus 2e to the inverse tan of x times x. And that's all over x squared plus 1 squared. So that was just quotient rule. If we set that equal to 0, we can see that we have x equals a half. So if we do our second derivative test, f double prime, now we plug in points around 1/2 to see the concavity. What happens? Here it's going to be concave up. Here it's going to be concave down. Okay. And now we can graph with the information that we have. So we have an intercept at 0, 1. So this would be 0, 1. We have an asymptote at y equals 4.8. So let's say this is y equals 4.8. And we have one at y equals 0.021. So let's say it's right here. All right, and now we can graph. So we know it's going to be concave up before a half. So let's say that this is, if this is 1, so this is a half. All right, so this is about a half. So here the concavity is going to switch. We have an inflection point somewhere here. We know that as it approaches negative infinity, we're going to approach y equals 0.21, but never touch it. And it's going to be concave up. So it's going to be like this. And it's going to be concave down after we get to that half. And on the other side, as x values approach infinity, y is going to approach this asymptote. So we're going to keep increasing until keep concave up until we hit the halfway. and then we're going to switch to concave down and approach this asymptote here.